Hello, everybody. We're going to conclude our exploration of nomenclature of monosaccharides. And, there's a disaccharide. Basically, it's two monosaccharides condensed together. So that's how we usually bring molecules together in biochemistry, right? Condensation. We'll see a lot more condensations before the end of the semester. So this one's going to be an O-side, isn't it? It's got an acetal over here. And I just want to remind you that group over there is a benzyl group. Benzyl. So the name is going to start with, let's leave room for work on the left. Benzyl, space, then a big word with pyranoside at the end. You want to put that down? Oh, I'm in jeopardy when I try to space things appropriately. How do we know it's a pyranoside? Ring size 6, yes. And this one up here will also be a pyranoside. And this will be a furano, and that's the anomeric carbon, and it's an acetal, so it's a furanoside. Got two sides here. All right, we got to unravel our ring. So right before it was this, OH there, CH2OH there. I'm going to put this H on here. It wasn't showing originally, but you know it was there. And we're going there, 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 there. There's where the aldehyde used to be. Down, down, and up. And to figure out what sugar this is, you need to get it back into the carbons being in a loop. They're not in a loop right now. The shape is not a loop. Look, they start out in a loop, and then they jag downwards. We don't want any jagging. I want the carbons to be in this loop where the OH is. It needs to have a carbon. That's this carbon right here. Fisher carbon rotation to here. OH will be up to the left. Oh yeah, up left, OH on the bottom stereocenter. That's an L sugar. Okay. What does he mean by L sugar? I'll show you. There's your aldehyde on the top. That's carbon number 1. 1, 2, 3, 4, 5, 6. 1, 6. Hey. OH, and on carbon 2, down right. Carbon 3, down right. Carbon 4, up left. After the rotation, carbon 5, up left. It rotated to where the hydrogen was. Hydrogen rotated to down right. And there you go. Now I'd ask you to look this sugar up on your handout, but you can't. You know you can't. The handout is D, monosaccharide, D, where this OH on the last stereocenter down is on the right. This is not on the right. So you want to look up the one that's the mirror image on the handout. The mirror image on the handout will be left, left, right, right for all the OHs. Am I looking at Manos or am I mistaken? So that D Manos, that's not our original, I'd like to remind you. Your original was L Manos. Okay. So we're there. We're ready. We're gonna do the whole name right now. Let's see. The O here is down and the CH2OH is down. They're cis to each other. That's beta. Beta. I'll highlight it because it has to do with those things being cis. And it was the L Manos. Beta, L, Mano, and I know I made a mistake. It's not a, well, it is pyranoside, sorry. It's not manoside, pyranos. Pyranos would have an OH here, right? This is a pyranoside because it's an O carbon. And there we have the final answer. We'll sneak it in over here just for spacing. Yellow. Nice. Okay. We didn't save our document yet. Okay. Next one is basically two problems in one. This breaks down to a 3-point question here that we just did. When we're finished our next one, 6 points. It's twice the work, worth twice the point. All right, so we'll do the sugar on the left in, on the top, sorry, in red, and the one on the bottom in hot pink. You're breaking that bond to open the ring up. So red. Red. Wonder if I can skip doing the ring. No, you're not ready yet. Just thinking out loud. Here's the red. It was an aldehyde. Okay. And it was down right, up left, down right, and currently down right for the H, up, there, and OH here. And we got to swing this so we're back into the loop. C needs to be in the loop. That's why we're doing this. Go straight to your Fisher. Oh, that's tall. It's very straight too. Oh, I can shrink it then. Okay, here we go. Aldehyde, down right, up left, down right. The H is now up left. The OH is now down right. This is a D sugar. CH2OH is in the loop. So which of the monosaccharides goes right, left, right, right? That's glucose, isn't it? Yeah. Could have saved myself a whole bunch of time. Looking at the chair that I drew in the start, all groups equatorial. Some of you have been reading about this already. Equatorial. That's why glucose is the most common monosaccharide on this planet. As all the groups equatorial, except for the anomerical. This one's axial. But that has nothing to do with glucose. That's how it got connected. So just remember, glucose, all of the stereocenters are equatorial. The original stereocenters. Yeah. D-glucose. The only reason we learned chairs was for now. You learned chairs on test 1 and 241 because we're using it now. Please don't say, oh, that was only test 1, 241. You know that's not how organic chemistry works. Everything you learned is important for later. Now is later, okay? So don't blow off chairs, embrace them. Okay. Next one we're gonna do in blue. It was a ketone. That's carbon 2. Oh, let's open it first. We got an OH there. Once again, a reminder, that's down right. What am I doing? Oh, I'm just drawing what happens after I open it, right? Okay, good. And that's going to go. And up left, down right. And there's your story. And we got to rotate the carbon into the rings, into the loop, sorry. The O is where the loop is. Now we can construct our fisher. We got, don't forget the CH2OH on carbon 1. This is a very common mistake. Students forget about carbon 1 for the ketoses. You can't. You'd have the wrong number of carbons. That's 2. See, I forgot about it. Guilty as charged. There's 1. 1, 2. 3 is up left. 4 is down right. After rotation, 5 will be down right. Wow, the bottom of this looks like glucose. That is how I learned you've got fructose. You just have to look it up. Lucky you. That should have been blue. The fructose. There you go. Now it's not clear to where the 1 is. The 1, right there. There you go. I don't think I can move this. Other parts came with. A little crowded over there, but I think we got it. Yeah, with a little knowledge in biochemistry of the glycolysis cycle, you'll know why fructose is the same as at the bottom as glucose. Because fructose is made from glucose, and glucose is made from fructose, and fructose is made from glucose, and it's back and forth. So they better be the same somewhere. And if you're curious, it's tautomerization that gets you from here to here. You do it twice. That's coming up. Naming. Okay. The red name. We've got D-glucopyranose. Now, is it pyranose with an E or pyranoside? Well, the only distinction is that the anomeric carbon, which is right here, must be an acetal to be a O-side. It must be a hemiacetal to be an ose. It's not a hemi. It's a geminal diether. It's an acetal. And the other one is D-fructofuranose. Once again, is it an ose or an O-side? This is the anomeric carbon of fructose. It is a geminal diether, also known as an acetal. If it had an OH here, then it would be a hemi. It's not. So it's an O-side as well. We're not quite done. We didn't do the alphas and the betas, and we didn't do the connection. All right. I'm pretty flexible on how you show the connections. You can do it in the middle here, between the two. The O here is trans to the CH2OH here. So that is alpha. Alpha D-glucopyranoside. Or you can move it in the middle and say alpha carbon number 1 of glucose is connected to carbon 2 of fructose, which is what, alpha or beta? I'm going to use a different highlighter. Let's see. It's a different story, that's why. Green highlighter. Green highlighter. There's the CH2OH. Here's the O. They're cis this time, aren't they? That is beta. And you can use the words connected in the middle here. Alpha 1 to beta 2. That's how you'll see I answer those on tests. That whole thing is the answer. Yes.
You have the same group on the bottom right. Why didn't you use that?
The bottom right here.
No. I'm talking about the molecules. How did you read?
Yeah.
You have the same one on the bottom right. Why wasn't that the one that you used?
No. That, if this is up on this carbon, then that must be down. There's nothing to describe. This is an irrelevant carbon. It will always be the opposite direction of this. It means nothing. So the convention is the group sticking off of the ring on the last stereo center, the carbon group, is what's used to decide alpha and beta. The last carbon down, or the lowest carbon down is what I should have said. Okay, so there we go. And try to get a square box. Didn't work last time. It worked this time. And that's the end of that activity. And we'll be getting some more